Hello, thank you so much for tuning into my YouTube channel. In today's video, I want to talk about digital colorimeter and how we can build one using Python. Let's get started. As I said in this video, I want to talk about digital colorimeter and how we can build one very easily. If you have ever wondered what exact color is that, whether it's on your screen, in a photo, or on a product you're designing, then you've already wished for a colorimeter. Traditionally, colorimeters are physical instruments used in the labs to measure color accurately based on how light reflects off of a surface. They're essential in fields like photography, printing, product design, and scientific imaging. But now, with the rise of high-resolution displays, screen-based work, and powerful software tools, we don't always need to buy a $1,000 colorimeter. We can build one in software, and that's where digital colorimeters come in. If you're on a Mac, you've probably used the built-in digital colorimeter tool. It's super handy. It tells you the RGB values of any pixel under your mouse in real time, and you can even adjust the sample area size from a single pixel to an average across a region. Designers, developers, and digital artists love it because it's fast, accurate, and always there. Unfortunately, Windows doesn't come with this. Not natively, at least. You'd have to install third-party tools, and many of them either look outdated, don't let you average color across an area, or aren't very customizable. So here we built our own colorimeter. We wrote a Python-based digital colorimeter that shows you the RGB values under your mouse, lets you choose the sample area size, gives you both the raw RGB from your screen and a calibrated sRGB value based on a real MacPath color checker chart, even shows a live color preview so you can see what color you're actually reading, and yes, it even shows a hex value in case you're copying it into design or code. We also built a transparent ruler box overlay that follows your mouse and visually shows the sampling area just like a proper tool should. Let's go to Python and show you guys how it works. So as you can see, this is the script that does the calibration of the digital colorimeter. First we import the necessary libraries, and then here is the path to the image and also the data on MacPath color checker under sRGB values. As you can see, these are in this folder. And then here we load the images, and then we're going to be dividing the image into a 6x4 grid. It's 4x6. Yeah, so the rows are 4 and the columns are 6, as you can see here. And then here we're going to be automatically reading the RGB values that the digital colorimeter is going to be reading from each patch. So the mean RGB values of each patch is going to be saved in this loop. And it's going to be saved in the measured RGB. And then here is the sRGB reference data from the mat file, which is here. And here we're going to be making sure of the size, which should be 24x3. 24 is for 24 patches and 3 is for sRGB channels. Then here we're going to be normalizing the values so that they would have the same scale, so that the linear regression would make sense. Almost like neural network, but less complicated here. And here we're going to be solving for matrix M that would do the calibration. So in other words, in this calibration, we're going to specify a matrix M that would be multiplied by the RGB read by the colorimeter, and that would give us the RGB calibrated. So to do that, we're going to use the MacPath color checker RGB value or sRGB values right here, and we're going to use it in this pseudo inverse equation to specify the matrix M that does the calibration. So when the M is specified, we're going to use it in this equation. So M is going to be multiplied by the data read by the digital colorimeter, and that's going to give us sRGB value. So the RGB calibrated here is the sRGB values of MacPath color checker. And these are also data from MacPath color checker read by the digital colorimeter. And we're going to do this whole thing automatically using the script that I showed you. So using the data from MacPath color checker, we're going to colorimetrically specify our digital colorimeter or characterize it. So these are sRGB values of MacPath color checker, and these are RGB values of MacPath color checker read by the digital colorimeter. So this whole equation is going to do that. And it's going to output the linear matrix here. Let's run it and see what happens. So this is the calibration matrix. So you got to copy that and paste it here, and I've already done that, so I don't need to do that again. So this is the digital colorimeter, and uses this matrix to show us the sRGB values. So first we import the necessary libraries, and this is the calibration matrix as I already explained. Then here is how the color sampling is going to be done. So the color sampling is going to get a screenshot, and then it's going to average the color over that screenshot. And here is where we're going to be updating the GUI. As you move your cursor, the values are going to be updated, as you can see here. So here the GUI is updated in terms of color, that it shows sRGB and also the native color and also the position of the mouse. And here is where rectangle is going to be drawn, which shows where your mouse is located at. And here is the main window of your colorimeter. Here are the variables that it needs, and this is the overall layout. And then we're going to also have a ruler which specifies the size of the region over which the color is going to be averaged. Let's try it and see what happens. This is the digital colorimeter. Let me go over a better page. Here's the colorimeter. As you can see, it shows the position, sample area, and here is where the sampling area is going to be adjusted. As you move it to the right, the sampling area is going to get bigger, and when you come to the left, the sampling area is going to get smaller, much smaller. This is just 1 pixel. And when you go to the right, it's going to be much bigger. Usually you have to keep it big so that it would be a more accurate color reading. As you can see, the color is going to be red. You're going to have sRGB, which is calibrated value, and then the hex value, and also the native RGB. This is the native RGB on your display. You could see when you keep it here, it's going to be a mix of all these colors. But when I keep this smaller, I would be able to read each color individually here. But when I keep it big, it's going to be an average. You could see the color here, other colors. Let's go for white, see how it looks. You can see that this is not 2.5, this is not 255, not 255 either, 240, 245. Let me make it a little smaller. See the color here. It's the red one. This is white. Other colors. Shades of yellow. You could see that the native RGB and also the sRGB, they're not that different. But now at least you know that you can read also the real sRGB values. Let me rainbow. I have to make it smaller. And here it is. This is a very simple digital colorimeter made in Python. And you could also have access to the course and also the data using the link in the description section of this video. And don't forget to calibrate your digital colorimeter. You need to have matrix M, and you have to first run this one. And for this one you have to specify where your data is located, which are these two. And after that you gotta copy and paste this matrix M, the calibration matrix, into this digital colorimeter here, right here. Hard code your matrix M here. And then you could just run this, and that would be your digital colorimeter. This hex value also shows the native RGB values, not the sRGB values. And that's about it. Thank you so much for watching this video. I hope you liked it and you also found it helpful. If you liked it, I would appreciate it if you could subscribe to my channel and also share the video with your friends. Thank you so much and have a nice day.